Okay, Lehigh Nation, what's up? So I was talking to someone about you know, solving equations where they had like root x, and square root of x or cube root of x or like something nonsensical like that, or x to the 4, or x to the 8, x to the 6. Um, what I was what I wanted to get at here was that some equations, if you're a newcomer to solving equations and you've just kind of done the typical quadratic, where you have to go x minus 1 and then x minus 1, right, which is x minus 1 squared. If you've only done that stuff, right, solving equations that have square root, so like for instance, x minus 2 root x plus 1. This doesn't make any sense at all, right? If you're new to it, this doesn't make any sense at all. So the trick, right, what you have to do is you have to bring it back to a form like this that you know, so that you can solve this guy, so that you can factor it properly, right? So for instance, if you've got this equal to 0, right, you gotta somehow make it look like something you know, which is like a quadratic, right, a squared term somewhere, right, so that you can solve the equation. Otherwise, it's not going to help, right? How do you solve this equation to someone who's brand new to this stuff, right? So what you do instead is you take the term that really bugs you, right? You've never seen this before, right? Which is the square root, and you call it some other letter. Okay, you call it some other letter. So you go z equals root x. This is a change of variables. You're changing your variable, right? You're not doing x anymore. You're going to put everything in terms of z, and you're going to solve the equation for z so that now you can solve the equation for x, right? So let's do this. So but if I replace root x by z, right, then I got to replace x too, right? X as well. How do I replace x? Well, if z equals the square root of x, what I can do is I can square both sides, right? And the square of the square root, they cancel each other, right? So I end up just getting x is equal to z squared. All right, so z squared, right, replaces x. And of course, z replaces square root of x. And the 1 is left unattended, so you go equals 0. Now this, I know how to solve, right? I know how to solve this equation. It's the same form. It's just x is replaced by z, right? It's the same form. So I know that I need two numbers that multiply to positive 1 but add to negative 2. So it's z minus 1 all squared. Okay, so that equals 0. Now the only z value that will work here is z equal 1, right? So that means that since I called z the square root of x, remember that? I called z equals square root of x. So I'm not done. I got to solve for x. So the square root of x then, right, if z equals 1, then the square root of x equals 1. That means that x equals 1 is the answer. Okay, now I'm done, right? Now I am finito. I'm finished. So x, let me go back and let me check to make sure that this solution works, right? This was the original equation that we started with. So let's plug in the x value. So 1 minus 2 times the root of 1 plus 1 equals, let's see. So the square root of 1 is 1, right? So this turns into 1 minus 2 times 1 plus 1. 1 minus 2 is negative 1. Plus 1, I end up getting 0. And that is what I should get on the right side. So I am good, and this is my answer, right? So that is essentially it, right? That is essentially it. You've solved the problem. Now, this is kind of like a simple equation, albeit, even though it's got root x, it's kind of a simple equation. What if we make things a little more interesting, right? So what if we have, x minus the square root of 4 minus 3x equals, 2 or something like that. I don't even know if this equation is going to work, but or if the equation gives me a nice answer for x, but let's just see. Now, again, before, right, I had called the nasty thing that I'd never seen before z, right? Now, guess what? I've never seen this before, right? So this is the nasty stuff. So I'm going to call that z. I'm going to call that z. So I'm going to say z equals the square root of 4 minus 3x. Now, before, I had the square root of x equals z, and so I had to make x equals z squared, right? Because I couldn't have x and z in the equation. That doesn't make any sense. I can't solve that. So I need to put everything in terms of z again, right? Again. So if z equals the square root of 4 minus 3x, before I had that trick where I had to square both sides, right? So I squared it, and that got rid of that, right? And so I had x equals that. I do the same thing. I square both sides. Okay. Now the square gets rid of the the square root, right? So I end up getting that 4 minus 3x equals z squared. Great. So now all I have to do is solve for x, right? So z squared equals 4 minus 3x. Okay. Add 3x to both sides. Okay. That will kill this, right? So I end up getting that z squared plus 3x equals 4, all right? Now take away z squared from both sides, okay? So I kill this off, right? So 3x equals 4 minus z squared. To finish off, I divide both sides by 3, and I get that x equals 4 minus z squared times, well, a third of 4 minus z squared, right? So this is what I get for x. So now I take all that I know. I take that z, that z equals this thing, right? And that 4 minus z squared over 3 equals this thing, right? So I go 4 minus z squared over 3, right? And then it says to just subtract z. And then I slap on a 2 on the other side. And notice, this I can solve. This is a quadratic equation in z, right? I've done quadratic equations in x, and I solved those before. So I can do this equation. This is fine. Okay, so to solve, right, I need like the standard form quadratic, like az squared, az squared plus bz plus c equals 0, right? I need that form. So this is looking nasty right now. I can't have a 3 on the bottom, so I multiply both sides by 3, right? So I go 3, and I go 3, right? Okay, so if I multiply 3 into this guy, that will cancel with a 3 on the bottom. A 3 on the top will kill a 3 on the bottom. Okay, so I end up getting 4 minus z squared. Now this 3 will also expand into this term, and so it'll be minus 3z. And then 2 times 3 is 6. So I've got this equation. It's coming closer to this form, right? Great, great. So next, I want my z squared term. I want this a to be positive. That's what I like. It's your preference. If you like a negative, you can just do that, right? It's no problem. But I like my a's to be positive. So what I'm going to do is I'm going to add z squared to both sides. Okay? So I kill this with that, all right? While I'm at it, I'm going to add 3z. Remember, everything's supposed to be on one side, right? So everything on this equation has to be on one side. So I'm going to go ahead and do all my magic. Add 3z, that will kill this with that. And then take away 4, right? Because this is a plus 4. Take away 4, take away 4, right? And so boom, boom. Okay, and I end up getting that nothing is on the left, which means 0, equals to z squared plus 3z, okay, plus 2. Now I think I'm in luck because this is easily factorable in z, right? This is a quadratic, two numbers that multiply to positive 2, only one combo that works. Sorry, two combos that work, but this one works in this case, right? So I end up getting that z plus 2, okay, and z plus 1 equals 0. Okay. And so from that, I can say that z equals to the square root of 4 minus 3x, right? And equate them, right? So I end up getting that it's negative 2 and, negative 1. Now the problem here is that with the choice that I made a choice of 2 here, right? That actually was not a good idea, right? Because now I've got no solution, right? No real solution anyway, like no number solution that doesn't involve a complex number. So that but this sort of method is basically how you get to your final answer, right? So you plug in your z and then you can find the x value. And so this is a change of variables that you can do, and you can do it every single time you see some equation that has like a regular x term and one that has like a square root. Every single time you can do a change of variables. Z equals to that nasty square root, and you solve for x, right? Had I chosen, I don't know, let's see, had I chosen negative 2 here, then I would have ended up getting a negative 6 here, and I would have ended up getting a negative 10 here. Let's see if I can get some answer out of this so that you can see what I'm talking about. So had I chosen that, then things would have been easier, right? So I would have had plus 5, right? It wouldn't have been easier, but I would have at least gotten a numerical solution, right? Z plus 5, Z minus 2. All right. That means that in this case, right, that that the square root of 4 minus 3x, right, Z, okay, equals negative 5, right? Because look, Z equals negative 5 or Z equals 2, right? So the square root of 4 minus 3x equals negative 5, or the square root of 4 minus 3x equals 2. Now this is a positive square root, cannot be negative, right? Cannot be negative, so this is not good. But this works just fine. So I square both sides. So 4 minus 3x equals 4. Cancel, right? Because I can take away 4 from both sides. So negative 3x equals 0. So x has to be 0, right? So that's my answer. So my answer to the original equation is that x equals 0, and we can see that if you plug it in, it works, right? So 0 minus square root of 4 minus 3 times 0. What does that equal to? Well, 3 times 0 is 0, so this cancels. This is gone, and I still have a minus there. I can't get rid of that negative. So I get negative root 4. Negative root 4 is negative 2. And so I end up getting negative 2. So my answer is correct. Again, this is a change of variables. You are going to do it when you have this sort of situation. This sort of situation where you've got an x, which you've seen before, but then like this nasty square root, right? So please apply the change of variables. If you have any questions, leave a comment, subscribe, like, share. Thank you so much. This is a course from UVU called MAT 1000. I think it was called, I think the course said, intermediate algebra or something like that. So yeah, so thank you so much, and have a good one. Bye.